Hello, everybody. I'm Povilas. I wear many hats, and one of the hats I wear is I coordinate R&D activities for more than 200 .NET devs. So what this means in human language is I look for cool things our guys could use in their projects. And one of those cool things that I found I want to bring to you because it's very cool. So I will talk about Semantic Kernel, which is surprisingly a magical way of integrating LLMs. Well, everybody's talking about AIs these days, and however you feel about it, whether it's a bubble or not a bubble, people will ask you, okay, so yeah, we don't care, it's a bubble, just let's integrate them. Like, we want investment fund money, give us AI, right? So finding ways how to do that easily is probably beneficial. So this is a tool that gives you exactly that, an easy and magical way of integrating LLMs into existing .NET applications. So let's start from the basics. What is Semantic Kernel? So lots of words. It's MIT license, meaning free for commercial use, open source SDK for C#, Java, and Python, made by Microsoft for LLM integration and orchestration, right? We will talk about C#. I don't do Java, I don't do Python. There are people who do that. Supposedly it works for them as well, but I know that it works for C#. Okay, so why does it matter? We can directly integrate with OpenAI, so why do we need a middle layer? So it is very modular as an SDK. It is some of the best people on Microsoft worked on developing it as an SDK, and you can really feel it. It is very easy to just get exactly what you need quite easily. Most of this, like I have 8 slides, most of this is going to be a code demo, and we will do a lot in roughly 40 minutes, and you will see how easy it is to get started with it. It easily integrates with local and cloud LLM providers, a whole bunch of them. From Ollama for local integration to Azure to AWS, doesn't matter. And it abstracts the specific details of those. It supports most models, including multimodal embedding, like text to audio, text to image. All of those are kind of supported out of the box. It has embedding and generation. It has vector stores, which is just a fancy name of saying vector databases. It has RAG support. It can call local C# methods or external tools, which in semantic kernel language they call plugins. It can call them via OpenAI. It can now call them via MCP, and it can even call Azure Logic apps for some weird reason. And it has integrated optional approvals. So out of the box, it also supports everything that you like about .NET, like the standard logging, out of the box. OpenTelemetry, out of the box. You kind of just get it and it works. And it also supports multiple agent collaboration. So it's a software development kit, meaning you have good basics, but anything advanced you kind of need to build yourself, which is exactly what it's for. Okay, how good is it? I currently rate it 8 out of 10, and we will talk about why that is in the end. As an SDK, it's really good, but it's Microsoft, so it has Microsoft problems. We will talk about them. Okay, so what we will do today in the practical part, that's it, that's all the theory you will get today, unless you come up and ask me something, but let's talk about practical application. So we have a very feature-rich and amazing application. We did a fictional launch, and we are getting fictional rave reviews. People love it, all is good in the world. Our application, and here's the entire architecture, and I use the word architecture here very liberally. Console UI, how we are used to console UI, right? Everybody uses that, like who needs web? 3 methods, get an uncompleted to-do list, add an item to my to-do list, and complete an item. Very simple, right? And I hear a fictional audience member in the back ask, so what's the problem? And the problem is we like money. And we want some sweet, sweet investment fund money, and we are lazy. So the best way to do it is to actually add AI to this. Did our users ask for it? No, they didn't. Do they get a choice? Nope, we will not give them a choice. So through the magic of PowerPoint, let's add the LLM. Bam, there we go. That's it. We get the investment fund money. Okay, so very easy on the slide. Let's see how easy it is in practice of doing that in C#. So I will switch to code now. Yep. So let me walk you through the amazing software that 20 developers wrote. So our to-do item is simple. We have an ID, GUID, int, doesn't matter. We have a string content for our to-do item. We have a Boolean property is completed. And we have a very, very basic constructor. So nothing special here. And we have our amazing to-do list service that does all of the heavy lifting. And I use heavy very liberally here again. So please pretend this is like the best implementation. If somebody asks you out of the conference talk, like say that, well, the talk about the AI was bland, but the to-do list implementation was amazing, right? So it's a list of to-do items, doesn't have any concurrency issues because we have only a single user, and we have 3 methods, right? We get a list of uncompleted items, we add an item, and we complete the item, right? I'm doing something simple, but in reality, it's applicable to more complex stuff. And then we have our amazing UI that our front-end developers wrote. So it's a standard console application. I will show you maybe the demo of it. So I can see, like you probably used and you probably wrote in university software like that, where you just like pick from 1 to 3, and then you do an operation. So that's our entire UI, right? Okay, what do I want to do? I want to watch all the Matrix movies, right? Very fast, and there we go. It's working. So I can even complete an item, and then I have an empty list, right? So that's our entire UI, that's our entire application, and what we need to do now is to add AI. So to do that, first, we need some semantic kernel, right? Actually, we will be using extensions AI and semantic kernel both at the same time. We will get to that whole thing when I talk about the disadvantages. But this is like the general abstraction layer. This is semantic kernel itself. And then you have specific connectors to 2 things, right? Ollama is a very, very amazing tool that lets you run locally a model and call it via an API call, like a simple HTTP call. And OpenAI is what we use to call the cloud. I will show you both of them. And let me just open up my side notes so I can copy some code. Okay, so we have what we need. We will only be using these right now. Where do we start? So the first thing we do is, for a console application, we need to have a kernel. That's like the core part of semantic kernel, the kernel. So let's do that. And we will start with a very, very simple kernel. You can do this via dependency injection as well. In console, I'm doing here. We are creating a kernel and adding an Ollama chat client. So chat client is going to be the interface that we do everything through. And here we have 2 options. One is the model. So Ollama 3.2 is a model. It runs locally on my machine. It takes 4 gigabytes, and it is surprisingly good. I'll show you. It kind of works. And then we have a URL. That's it. We have the kernel now, right? And then we build the kernel. You can add some other things, like logging. I will show that a little bit, but let's first do something with the kernel, right? So the first thing we do is we added the chat client. Let's actually get the chat client. So like typical dependency injection thing, I get an interface, I chat client. Okay, so what do we do with the chat client itself? Well, the first thing is we fire all of our front-end developers and we get rid of everything here because we no longer need an UI. LLM will do the UI for us. So I will add some code here and walk you through it. So the code is very simple, right? The meat of it is here, get streaming response. So you have 2 methods here. get response and get streaming response. The difference between this is the get response is what you would normally use. The streaming response is what you will use for conferences, because it's like streaming one token at a time very inefficiently, and then it looks nice on the screen because it's like writing things out. So it's a conference, so we will be using this one. And then we have some, well, it's no longer black magic, but kind of magic through a sync enumerator to print out the text. This is only because this is a streaming response which returns an async enumerator. If it's like a single response, it's a string and that is it, right? So this part you can pretty much ignore. Okay, one more thing I want to show you is I want to add some logging, right? And I said in the previous slides, it's very easy to do, so let's do it. Probably wrong place, maybe here. Yep, and that is it. I'm adding console logging. I'm setting up log level error, like the same way. If I was doing dependency injection, it would be the same way. And that is it. I will get logging. I'm logging at an error level, and I'm hoping my presentation will not have errors, so you will not see in action. I can put it on trace level, then you will see every call that is made. It's going to be a bunch of text. But this, surprisingly, is this easy to add some logging. Okay, so we have done something. Let's actually see how it works, right? There we go. I would like to watch, no, like it's an LLM, watch all the Matrix movies, figure out what I want. Of course, it's a trilling. So as you can see, the LLM is already there, right? It's doing something. It's not using our C# code, right? Because we never really did anything to integrate it, but it's kind of already doing that. And I could ask it to add some to-do items, and it would add some to-do items. Problem is that I'm only kind of passing one message at a time now, right? So what's my to-do list, right? And it's kind of just one thing at a time. If you're doing one-shot prompting, that's it. That's everything you need. Like this is enough code. But we are not doing one-shot prompting, right? We need some sort of a history and some sort of a memory. So Semantic Kernel calls this history, and let's maybe add some history. So we add history. Again, you will see I'm kind of talking about maybe smart concepts, but the code is very, very basic. It's the same typical things that you use in C# that you always did. So our history is just a list of chat messages, and chat message is a class that comes from extensions AIs, and it essentially, even it is very, very basic. We have a chat role, so meaning, is it the user? Is it the assisting, meaning the LLM? Is it the system, meaning it's like the advanced prompt? Or there's also tool, I think. Yeah, so if you're calling tools, tools also kind of go into the same chat. Okay, so I think I am missing an intro message. And where is my intro message? Or no, okay, let's just write an intro message then, because I seem to have eliminated it. Okay, so our intro message is going to be what we want. No, wait, it's fine. Well, it's a live demo, so of course it's not gonna be, yeah, there we go. I just put it in the wrong place. Okay, so we have a history of chat messages. What we are adding is the system role. So you are a to-do list management software, so we're giving it some context. You can work with to-do items, communicate with the user in natural language, do not deviate for this or anything that's unrelated to the to-do list management, right? And I say that, and we all know prompt injection is a thing, so this can be bypassed. Not getting it bypassed is gonna be complicated. So only respond based on the plugin responses. We don't need that just yet. Never ignore the system prompt. Again, kind of repeating myself, we all know this can be bypassed. So probably a good thing to talk about is the input here, right? So while we were doing our basic console application 1, 2, 3, the input validation is stupid easy. If it's not 1, 2, 3, get out. right? Now, the input is abstract, right? So you would need quite a significant validation layer here to figure out whether you're trying to be injected. Again, if it's for internal users, maybe it's different, but if it's external facing, you would need a bunch of logic here, and you would probably need a bunch of logic before you print out the response. You would need to both validate what comes in and what goes out. But we are not too worried about that in our application, at least not yet. So let's continue adding history, right? So we added history here. Now we need to actually do something with the history. So the first thing we need to do is we need to put in the input, right? Very simple. To the list, we add a chat message with input. And now we need to actually pass the whole history into our chat client. So let me go and replace this. Not a lot has changed. So the main thing that changed here is that we are passing not the input message. So it's no longer a one-shot prompt. We are kind of passing like everything, the entire context, the last message user asks something, and we expect the agent to respond, right? And the rest of the code is kind of the same. There is a little bit, for those that noticed, a little bit of a change because kind of with this streaming response, we have to also put it somewhere. So we're using a string builder here, and we are adding it to the history. So like the response doesn't get automatically added to the history. The history lives in our machine, so we need to add it here. Okay, so we added history, and let's maybe look how it works now. So we still have not yet integrated our C# code, but we have done a lot. So watch all the Matrix movies, right? And here I'm using a local model, and you will see it is able to handle the queries relatively well. Okay, it added something to my to-do list, and a cheeky audience member might ask, where is the to-do list, right? There is no backing implementation, and for now, it's in the LLM memory, right? So if I ask it, to-do list, it's already kind of failing, right? It has the memory, and it should remember, and I think if I will ask, yeah, you can see it failing. Your current to-do list is empty. Would you like to add a new task? Remember, I have the previously added task. So what's the status of my to-do list, right? And we all know LLMs are not deterministic, so they're not very good at things like a to-do list. And here is where C# comes in, because we can still use our service for the backing implementation, right? That's what we want, deterministic output, deterministic input. So that's the next thing we are going to do. So first thing we need to do is we need to add some information. So we will modify the to-do list service class, but not really. So we will add some context for the LLM, right? And there are multiple ways you can do this. You can do this via attributes, like I will do here now. But you can also do it without even touching your service class. So here, what I'm doing is I'm telling it that this method gets a list of uncompleted to-do items. It only gets a list of only uncompleted items. You should call this when the user asks for a list of items in some form. You should also call it every time you do an action that changes the list to get the updated version and only report that to the user, right? And this part is kind of important, right? We are instructing not only what the method does, but how it's intended to be used, right? We always want the newest version of the to-do list, so we need to put that in the context, right? So let me add a few more descriptions. Those are going to be simpler. Again, it's very complicated software, so yep. So here for the complete, right, we tell it what it needs to get, right? It is able to see the parameters, their types. It's able to figure out to some extent how to call them, right, and what to call them with. The better models do better at that, but we will see that. And that's it. That's everything we need to do on the service class. So now we actually need to adjust the prompt a little bit, the system prompt because we want to tell it, it's pretty much the same. This has changed, right? Use the plugins to perform the tasks, right? And probably if you are unable to do that, let the user know, and that's pretty much it. And only respond based on the plugin responses, right? So we're kind of heavily steering the LLM to always use plugins and use them the way we intended, and you will need to do that, especially if the plugins become more complicated. So, okay, how do we actually integrate the code? And here we need one more object that's called chat options. Again, it comes from extensions AI. So it has a few properties. The tool mode essentially is none, manual, or auto, meaning, no, not manual, auto, sorry. None require any or auto. So none means don't use any tools. Require any means use at least one tool. Auto, figure it out yourself. Allow multiple tool calls. Just call once or call them in a chain. And then we actually tell you what tools you have. So we use an AA function factory and we create. And the create is not very complicated. It just takes a delegate. So it can be pretty much any function. It can be a custom function that you write here, or it can be a service here. So what we can do, we have another parameter of options. So in those options, we have a few things that might be interesting. So probably the single thing, if we don't want to touch our service class, we need to put the description here, right? That way our service can stay completely the same way it was, and we can still get the function called. So I put it in the attributes because it's nicer to see in the demo, but normally I would probably put it somewhere here or even in a separate class. So, okay, so we have this chat options, right? And now we need to actually do something with them, and that means we need to pass them here. So, let's do that. That's it. That is actually, I have some code here. No, that's probably it. Yep, and that's actually enough to get our code being called. And to show that, let me put a breakpoint and let's run it and see what happens. Okay, watch all the Matrix movies for the third time. Well, it's the first time for it, it's the third time for me. You will see immediately that it got slower. Why did it get slower? Because now what's happening before was like we are shooting off a prompt, even like shooting off, it's local, but we're still shooting off a prompt, and we get the immediate response, right? Now there are more responses because we are getting like, do you need to use any tool? LLM figures it out, right? Okay, I need to use this tool, and if there are multiple calls, there's like much more HTTP calls, right? And as you can see, it is hitting our breakpoint now, right? So for now, our to-do list is empty. And actually, let's add maybe to add as well, just so we see what it decides to do. And none of this is deterministic. Every time you will run it, you will get some varying result, right? What is my to-do list? Okay. As you can see, it's like it's running locally, but it's significantly more slower. And again, some of that is on my machine, but let's see what we have in this collection. We actually don't have a to-do item, right? So as far as LLM integration goes, this is a pretty big failure, right? And you can get it to work, right? Add the matrix, my to-do list. Sometimes it's even hard to figure out whether it's working. I've been running these demos, like it's the third time I'm running, and every time kind of catch new things. Okay, so adding something. Okay, so adding something, and probably we will get that out, right? Not good. Not good for our investment goals. And why is that? The model that is running locally, it is able to produce relatively good natural language. Doesn't have any kind of mistakes. If you look at that, the text looks reasonably well, but the model itself isn't as good, right? So the final touch we will change is we will get some investment from Microsoft, and then we will use it for Microsoft consumption, which is the popular thing to do these days, and we will actually switch to GPT-5. So for local testing, for speed, Ollama 3.2 is really good. If you're just testing the workflow, really good. You don't even need internet for that, right? It's running locally. So we will switch to a smarter model to see what actually happens, and maybe just let's replace all of that. So I'm switching to a different provider, and I'm switching to a different model, right? And let's maybe copy this, just so it's very visually apparent of how much of a change that is. The model name has changed, right? Very big. And the URL essentially has changed. Well, this is not a URL, right? It's like an endpoint and an API key, but it really is a URL, right? So we changed the endpoint, we changed the model, and that's enough for it to work, right? That's enough to switch providers. That's enough to, like, we don't need another SDK. We essentially just switch to another package, called a different method, kind of passed the same things, and that is it, right? So that is very powerful. You don't need a specific SDK. Extensions AI and Semantic Kernel abstracts all of that from you, and let's see what GPT-5 Mini can do. Okay, I want to watch all the Matrix movies for the fourth time this time. Okay, so let's look at, yeah, okay, the model is lazy. So normally when I run this demo, that's where we see the magic of LLM. Okay, let me be a little bit more specific. Watch all the Matrix movies. Okay, add these as separate items. And this is where the LLM actually has some additional value to the users, because right now it didn't have additional value, right? But here, we should start seeing some additional value, is that it knows what the Matrix movies are, it knows how many of them there are, and some other things, right? Okay, so we have 5 items, right? All the 4 Matrix movies. I've heard there was any Matrix as well, right? And this is like, if I was writing custom software with like the console, figuring out what the sentence means would be an absolute nightmare. With LLM, it is able to figure out that we were talking about like watching movies, adding things to my to-do list, so it knows it needs to add any matrix by default, right? So that is some additional value. Whether it's better than the console interface is a different topic, but some additional value is definitely there. And just to show you what is actually there in the list, you will see that we have the entire list there, right? It's backed. If we are storing it in a database, that is it, right? We have determinism for C# code, and we have the approximate input-output for the LLM, and that's probably the best combination that you can have, right? And same way I can do it, like, let's just hit continue here. I can add some, watch all the Lothar movies, and Star Wars, right? Again, approximate out. If I ask the user, like if you were programming this UI and you wanted to process all of this, you would have to figure out what Lothar actually means, what movies are there. You would have to have an entire database of movies, and it would be an absolute nightmare. Okay, lazy LLM. Thank you for making this easy. Add Lothar movies and Star Wars movies as separate items. And you see I made a mistake there, and I'm not going to correct it because LLM is happy to handle these kind of mistakes. it tokenizes those words. This is kind of more or less the same as movies. So, what is it? Maybe I just killed ChatGPT. Or no. No, it's working. It's just like adding probably 8 or so. No, wait, how many Star Wars we have at this point? Probably 9. Okay, there we go. So we have Lord of the Rings, right? The 3 movies. We have The Hobbit, which is questionable whether it's Lord of the Rings or not, but for LLM it is, at least this time. We have Star Wars, right? Maybe not ideal. Maybe I would want episode 4 to be before chronologically, right? But that's what we have. And for our users, right, this is quite powerful. You saw, like, I wrote relatively little text, and I can get all of these to-do items, right? And I can tell it, like, I've actually watched the original Star Wars trilogy. So complete those items. And what it's going to do is actually it's going to call the complete method 3 times. It should, at least. And it should probably call it for these 3. So let's see whether that happened. Where is our output? Yep. It knows what is the original trilogy of Star Wars, right? Because it had that in the training data, it had that in the context, and it is able to complete those 3 items, right? Pretty powerful. And not a lot of code. Like, if you need to show an MVP, if you need to show a POC to your customer, this amount of code, okay, I wrote it maybe 3 times so I can do it in an hour, but it's gonna take you a day or so? Not so bad. Okay, so that's actually my code demo done. Phew, that was the hardest part. So what did we do? So we integrated Semantic Kernel into our application. We set up an LLM conversation. We set up memory or history for chat messages. We integrated our C# code services into the AI. We switched between providers and models without really changing our code, and we did that in roughly 40 minutes, right? Very good for the conference. Most importantly, we got fictional investment fund money, and now we will take a vacation for 2 months. So, I hear the cheeky audience member that's fictional from the back again. It looks very cool. Everything that you showed here is very nice. Why isn't it 10 out of 10? So, 2 reasons. One is the underlying technology is rapidly changing, but I can't blame Semantic Kernel for that, right? LLMs are being figured out, right? This year we have agent mode. Next year we will have schmagent mode, but can't blame that. The semantic kernel itself is also rapidly changing. So I originally did this research maybe 8 months ago, and it got 3 breaking changes since then. So it's very hard to keep this up to date. That part is complicated. And what is worse, it's a very big bullet point, is that there is a lot of overlap. So there is Microsoft Extensions AI, there is Semantic Kernel, and now there is Microsoft Agent Framework, and they all do the same thing. Like, I'm not joking. They have the same, like, interfaces that do the same thing, but they do it in a different way. Right? So now I was mostly using Extensions AI because that's the Microsoft recommended way. So like originally Semantic Kernel came out first, so it had all of its own abstractions, all of its interfaces. Then they moved it to Extensions AI, but they didn't remove the original interfaces. So Semantic Kernel has overlap with Extensions AI, very huge. You can do everything without Extensions AI. You can do everything without Semantic Kernel. I say everything, they have some differences. In general, Extensions AI is like, if you want to just consume and use the LLM a little bit, use that, use Extensions AI. If you want to develop a multi-agent system or something more complicated, you would, like, as of 2 months ago, you would be using Semantic Kernel. From October, Microsoft Agent Framework came out, and that's supposedly the successor. Doesn't have full feature parity, because of course it doesn't, but it kind of is there. Like, that's the next step. So that's bad. As a developer, that is very bad. It's rapidly changing. It's hard to figure out what you are supposed to use. Even in Semantic Kernel, one of the research I did was on RAG, right? There are two ways to do RAG in Semantic Kernel. For some reason, it's a very small SDK. Very simple, but there are two different ways, right? And the documentation is mixed. So you maybe are reading like one paragraph, oh, if you're using this, use this, and then suddenly it switches to another mode of doing RAG, and that is not easy for developers. The first time you will do that, you will get confused. So that is why it's not out, like, it being from Microsoft, it's not why it's 10 out of 10, right? It's still very good. It's, as an SDK, it's very nice. It was developed very modularly. As you saw, it's very easy to get started. It's very easy to do something with it, to play around it, write your own agent for internal use. That's enough. Like everything I showed you, you can write your own agent, right? You don't need anything. You can run it locally. That is it. In production, like, it has those gaps. Okay. That is it.